Dividing complex numbers. When we divide complex numbers, we want our final answer to be in the form of a complex number, a plus bi. In this first example, we've got a real number in the denominator, 2, and so that 2 has to be divided into both of the items that are in the numerator. So this would be 3 over 2 and 4i over 2. The 3/2 can't be reduced, but the other fraction can change into a 2 times I. So this is our final answer. It's in the form of a, which is the 3/2, plus bi, where b is equal to 2. In this second example, we have a complex number in the denominator, and so we can't easily divide the way that we did in the last example. What we do instead is we use conjugates to get rid of that I that's in the denominator. So the conjugate of 4 minus I is 4 plus I. So I'll multiply both the numerator and the denominator by that conjugate. So let's do this. Let's do some side work here. 2 plus 5i and 4 plus I. I'm going to get 8 here plus 20i plus 2i and then plus 5i squared. So this is 8 plus 22i plus 5i squared. This changes into 5 times a negative 1. Or minus 5. And then combining the 8 and the 5 together, we get 3 plus 22i. So that's going to be our numerator. When we multiply conjugates together, because the one of them has a positive sign and one has a negative sign in the middle terms end up canceling each other out. If I multiply this, I'll get negative 4i, and this gives me positive 4i. So all that I need to do is square the first two terms, 16, and then square the last two terms, minus I squared. I squared is negative 1. So this changes into 16 plus 1, or 17. So my denominator here is 17. For my final answer, I'll just split this up into its real part and its imaginary part.